So building a credit card issue with Elixir, I think the first thing we need to explain what is a credit card issuer and what is Brex, because I'm actually going to go over what we built in the last 2 years. Basically, an overview of our architecture, why we did choose to use Elixir in the first place, especially 2 years ago, and the challenges we faced, some stuff that was initially a good idea with Erlang and Elixir, but it turns out that for our specific architecture, they weren't specifically good choices, and what we did to address those. So first of all, what is Brex, right? So Brex is a financial platform. You guys, people who live here in San Francisco, you guys could have seen like a lot of ads about the Brex credit card. But I like to say that we are actually a financial platform and an infrastructure disguised as a product. And our main product today is the credit card. But that's not the only thing we wanted to do over time. So that's something that needs to get reflected in our architecture as well. And well, before we jump into all this stuff that we have today, I think we need to address how payments actually works. So people can understand some of the constraints that we face, some of the difference from, how can I say that, mainstream applications. There's some very specific stuff, but mostly it's a very common application. But well, payments in theory, pretty simple, right? Have A and B. B wants to buy something. A wants to sell something. They exchange money. But that's just theory. In real life, people generally say that this is boring because it's pretty simple, right? But in real life, payments is very complex. Very complex. This is payments. Of course, I just threw a bunch of images in there, but the point is, those are actually things explaining specific parts of payments, how they work, how banks exchange money behind the scenes, how for example, if you are in China, like in the middle of a small city, and you swipe your, I don't know, Chase card, and that works very well, and how that works. But basically, if we focus on credit card, this is kind of the picture that we have. And basically, we have three main entities working together. The first one, and most important, I'd say, that is the credit card network. Visa, MasterCard, American Express, all of those guys. But the people that actually do the work here are people that they're called the acquirers and the issuers. And basically, an issuer is a company like Brex or most banks, where they issue credit cards so people can buy stuff. And on the other hand, you have a thing called acquire. This is less well known, except for people who work with e-commerce or they had to receive payments. And an acquirer is basically the company that provides the merchant the ability to receive those payments. So if you have like a regular, I don't know, a coffee shop, that's probably like a Square machine that can read credit cards and process the transactions. But online you have Stripe and the old school guys that are mostly banks as well. So you can see that banks, they tend to dominate this payment space. But this is changing over time. And specifically about the payments network, which are mostly what we have to interact with on the credit card product, we're talking about very old technology, very scarce information on how to actually do stuff. Even if you ask for manuals, like the documentation that they provide in order to integrate with them is not that great. And this is interesting. The most recent from-scratch implementation, other than Brex's one, it's kind of like 10 years old. So you can probably see that nothing has changed in this space that much. People usually tend to build stuff on top of existing platforms, and that's one of the reasons why payments hasn't changed a lot in the last years. I mean, mainstream payments over credit cards and this kind of stuff. And while we have some different constraints, and we can borrow the CAP theorem here to talk about them. So usually people tend to talk about correctness, availability, performance, all of that. And in our case, performance isn't much of a problem. And every time I say this, people get scared because, well, what do you mean? Like, everyone uses payments, right? But if you think, please note that this only applies to this specific use case of accepting credit card transactions, right? Because if you think about it, the maximum number of, I'm sorry, I have a typo here. I'm missing a zero in there. But the global throughput, the average is 15,000 transactions a second. And that you need to consider Visa, MasterCard, like every single credit card and bank in the world. So if we're talking about a specific issuer, for example, even the big ones, they don't have anything close to this. And that's why I tend to say the performance is not relevant when you're building these types of systems, because overall, you don't need to do much in order to achieve this, as long as you have like a stable infrastructure and all of that. You don't have like to reinvent the wheel to achieve this type of throughput. And for example, Visa's maximum theoretical throughput, this is a number that they published, is around 50K per second. So, I mean, not that much, especially if you compare with really massive things like Facebook or social media in general is a great idea, for example. So availability is something very important. No one likes to get a decline on their credit card, especially if it's not their fault. So you can imagine that if a bank goes down and you're trying to spend your hard-earned money and you just can't because your bank is down, that's not a good experience. And recently we had a case related to this. Wells Fargo was down for like a couple of days, and that brought a lot of problems to people. And well, people just expect their money to be always available, like all the time. You just don't think as a natural thing someone can take away your money and you can't access it. Like, it's not normal. And correctness is also very important. Especially with financial information, if you're giving bad information, people are making bad decisions on top of it. That could range from people buying stuff where they don't know how much money they actually have because they're displaying wrong information, from actually collecting and transferring wrong amount of money from someone else's account. So you can probably see that as a financial infrastructure, those two things are very important to us. At the end of the day, we are just dealing with someone else's money. So after that small introduction, I think we should go on the road so far, what we've built so far. And I think that the first question is why did we choose Elixir? So there's a funny story on how we actually chose Elixir, and it's actually very random. So about 2 years ago, Pedro, one of the co-founders, we used to work together back in Brazil. We had a payment company there as well. And he called me and he was like, yeah, if you would start something else kind of related to payments, what would you use? And at the same time I was studying Elixir, I was, this looks cool. It has like resilience built into it. Of course, you need to really do the correct way of doing it to get all the benefits. But I was like, yeah, that sounds like a sane choice, although it's not so popular compared to other languages, but it's getting good. And a bit of background here. Our previous company was Node.js. And we started with Node.js 0.6, so you guys can probably see that we are not afraid of picking technologies based on their benefits, just because they are new, and new between quotes, because Elixir might be somewhat new, but it's running on top of a very battle-tested VM that is the Beam, which is basically around since the 70s or what, when it was built by Ericsson. And yeah, we also tend to love functional. We tend to see that, especially dealing with money, one of the easiest ways of not committing mistakes is not getting confused with global state, reassigning variables, that kind of stuff that generally leads to bad logic. And we've found that so far, by using functional languages or functional approaches, you can do that in JavaScript as well, you tend to avoid a lot of those mistakes, or it just makes the logic easier to understand. Because for most people that don't understand financial stuff, it's a little bit hard when you get to the tricky parts, like, for example, calculating interest and this kind of stuff. So so far our experience is that functional style programming is easier to understand than imperative ones for this kind of things. So yeah, Elixir was a functional language with a battle-tested runtime. One of the things that I personally really like about it is how macros are implemented, which of course you can shoot yourself with that. It's very easy, but when you have a lot of repetitive stuff, and you tend to have a lot of that when you're building APIs or more infrastructure-related, code infrastructure-related stuff. And the way that Elixir implements that has nothing to do with, for example, the first thing that came to my mind before we started using it, that was like C preprocessor. That's like basically copy and pasting templates. With Elixir macros, I should have included a slide on this, but you can, it's actually kind of dangerous. I can write some malware that can get executed when you are compiling the code. Because the reality is, with Elixir, your code is actually running inside the compiler, just like it was part of the compiler when you're doing macros. So it's an interesting side effect of that. And well, Elixir was also built with distribution in mind, mainly because it was built on top of BIM and the OTP. And the OTP is fantastic for that. And well, there's much more stuff involved in this. Overall, given the choices that we had at the time, if it weren't for all of that, Elixir would still be a good choice. It's a pre-syntax Ruby inspired, different from Erlang. I'm personally not a big Erlang fan, sorry, because of the syntax. But Elixir, it's overall pretty good for that. But at the same time, we got some stuff wrong. And I don't know exactly why it was that, but a lot of people tend to assume that just by using Elixir, oh yeah, you're safe. You can scale horizontally indefinitely. You have resilience. It's very easy to do cross-service communication. But in reality, when you get to actually trying to do it, you find out the very old truth that is there's no silver bullets, and you actually need to understand correctly how everything works in order to actually make it deliver their promises. So some stuff that we got wrong here is that distribution is very cool, but it doesn't solve all of our problems when we're talking about building a distributed system. When I said distribution here, I mean talking about the Erlang distribution with OTP. It's not that useful at the beginning because you're more focused on actually building the logic and, I don't know, getting your first customers to join your platform. And it's very hard to interrupt with if you have other tech stacks in your company. So in our case, for example, 99% of what we do is Elixir, but the most data-intensive applications are actually handled by our data team. And this ranges from analytics for the company to actually underwriting the customers, that is giving the credit limits. All of those algorithms and all of that stack was built with Python because that's mostly what the data engineers are using. So we found that having a way of interrupting between languages is very useful in our space. But if you only rely on OTP to do that, you're not getting all of it. Of course, you can build something. You can use maybe NIFs on the other side to do it. Not a good idea. You could try to just re-implement the OTP protocol. After all, the Erlang term format is somewhat a standard. But nah, it's not. You're kind of hacking it if you're doing that. Second thing, and I'm going to talk about the actual solutions that we found after. So hot reloads are very useful, and we actually have one very good use case for it. But for most of the applications, the way that we build them, we don't tend to have state on those applications. So, and when you do have state, it's kind of like applying a database migration every time. That's the code you need to write. So you're basically changing from writing migrations on your database to writing migrations for your own code when you're doing hot reloads. And well, in our use case, it's not that helpful, except in one very specific thing that is basically We have when connecting with MasterCard, for example, we have to establish a persistent tunnel. That's basically a TCP connection that can never go down because they are from this point in time where applications never went down. Nowadays, we're getting to a point where people are like, okay, we can just do, I don't know, blue-green deployments and this kind of stuff. But MasterCard is still stuck in that era. So that means that we need to reduce the number of reloads that we do in our code or closed connections. But at the same time, that's the most critical piece of code that we have and that we upgrade every day with new functionality, for example. So hot reloads in this case, it's very useful. This application is almost stateless because it's most about parsing their protocol and talking with other systems. And if we do use hot reload here, then we don't need to close the TCP connections, for example. So there are definitely use cases for this, but for most of our systems, those weren't really a really good choice. And the tooling for Elixir and Erlang, it works very well alone. But some are hard to integrate if you have other stuff in your stack. For example, hot reloads again. We use Kubernetes to deploy. So if you're using containers, of course you can kind of violate the principle of not changing the data inside your container. But it's somewhat tricky to integrate that with a system like Kubernetes because it wasn't built with actually pushing new code into an existing system and then reloading it. But of course, as always, there are ways around it. You can make it work when you need. For example, on this TCP connection example that I gave. So yeah, after those tricky parts that we had, we came to what we have today. And going over basically what is Brex today, we tend to say they have those 3 layers, and all of those things, they are at least one independent service. So we don't like to use the word microservices, so sometimes we replace with service-oriented architecture. At the end of the day, it's just the same thing, kinda. But yeah. And in our architecture today, everything is service-oriented. So we have independent and isolated services. They don't share databases, and every time they need to communicate, they need to use some sort of cross-service communication. And mostly our applications are stateless. For example, we tend to store almost all critical data in Postgres, although we have some other databases for more specific use cases. But the application itself with the business logic is mostly stateless. And on the public side of the infrastructure, if I can call it that, we have a GraphQL API built with Absinthe, which is a great library. I recommend everyone to take a look into that. And we also have RESTful APIs. The main reason why we have both is when we are integrating with third parties, well, in this case, third parties are integrating into us. GraphQL is still not a very widely adopted thing, and if you happen to provide RESTful APIs at the same time, this is very useful and can speed up things. And when talking about this system specifically, we don't have any front end. The front end is a React application built on top of the GraphQL API, so it's a thing completely apart. So I'm not going to go over it here. And yeah, today this is what our umbrella looks like. We have about, 20, 25 different services in there. Some of them there have multiple things like client server, but I think that overall there are 25 services today. And well, Brex 0.1, which was the first version of this architecture, the first iteration, and was basically with what we launched with, was basically an Elixir umbrella. We're still using it. Service-oriented architecture, and I'm going to go into why the quotes in a second. And we had about 10 services, so not the craziness that we have today. So, and yes, it was distributed, but not so much. When we started the company, we realized that building everything as isolated services was, given the past experiences that we had, was something very important, but at the same time, we didn't want to commit too much time to actually implement it, like cross-service communication and this kind of stuff. So we come up with a very clever solution that is, we have an abstraction to building services and doing cross-service communication, but we didn't care about implementing serialization or service discovery and all those pieces that you need. And instead, we relied on just doing kernel.apply, which is basically just running all the services on the same VM. The important part here is the services themselves, they don't know about this. They really believe that there is latency between them, and there is an abstraction that we can just plug another backend, which is what we did later, and replace that with a real cross-service communication. Then we got to Brex 1.0, that is basically what we have today. So still the same thing, an umbrella with a service-oriented architecture. Today we have about 20 services, a little bit more than that. And the important part is we finally solved the distribution problem that we had. Today we do cross-service communication using RabbitMQ. There are some reasons why we chose that. The first one is the architecture is mostly based on eventual consistency, which is the easiest way of building a distributed application. You don't care about ensuring strong consistency. You still care about consistency. And we found a very easy way of implementing services using that. That is basically just guarantee that all your services are idempotent, all the ones that actually need to perform actions. And just guarantee that every time you tell a service to do something, it will do something until it does. So if it crashes and it is idempotent, you don't care. You just wait for something to retry the function call. And by using queues to do that, we found it was very easy to, with a very short time of implementation, to make sure that everything was following this. So basically, we chose RabbitMQ. Reason for that, it's a Erlang implementation, so we can reuse all the tools that we had for monitoring, for example, and deployment. It will ensure the redelivery of messages because it's a message queue. It's interesting implementing RPC over message queues, but at the end of the day, it's working great. But we know that at the end of the day, it will become a bottleneck. First, because there are some functions that you call cross-service that they don't need all of those requirements. For example, if you're performing just read operations, they tend to be pretty I/O intensive, and you don't need to retry those because if, for example, the caller dies, and let's say everything dies, and there's no point in retrying this function because there's no one waiting for the reply anymore. The caller died, and you will actually call your function again. But so far, for the current volume that we have, it works pretty great. But that's definitely something that we're going to address later. And well, infrastructure-wise, and it goes back to why is it hard to integrate some of the tooling with some new infrastructure. We have this today. Basically, deploy everything with Kubernetes. This is actually a screenshot from today's production. There is plenty of more deployments in there. So yes, we are basically delivering Elixir today with Docker containers. Everything is running on AWS, and we still do mix. We didn't get into doing releases yet. There's not a reason for that, but when we first did this and we just used a mix approach to delivering it, it was just working. There are plenty of issues with that now that we have a lot of services. The build times are higher because the image is just too big for each service. Configurations using mix config is somewhat tricky because if you change an environment variable, it might want to recompile your code, so it takes a little bit more of time to actually bootstrap your application when you redeploy. So we're looking into integrating probably distillery. I think that's the easiest way of doing it to our build steps. But so far, we're still doing mix. It's working great. So yeah, and now I think that this is the most interesting part because so far, most of the stuff that we built was in order to get what we have running today. Which, I mean, it's not a simple application, but it's also not the most complex application in the world. But as soon as the company starts to grow, we will probably want to go into more financial verticals, for example, who knows what, we could be doing lending, we could decide to go the Robinhood path and maybe introduce checking accounts. Or we can, for example, go into securities. Basically, back to that point, we like to consider ourselves a financial infrastructure, not just a credit card application. So we come to a point where we need to ensure that everything that we're building today will support all of that. And most importantly, that everything that we build in the future will be able to reuse the systems that we have today. Because, for example, we have very well built systems for delivering notifications and communications to our customers. We have systems for accounting, which is something very important on financial systems. And if you don't reuse like the common pieces that you have, you're basically throwing away engineering time. So this is something that will be very important for us. So we like to call it Brex Infrastructure 1.1 because we don't want to change radically how everything works. But I think that there are two very important points. The first one that I made, and the second one is to have how we do stuff very well defined. So when new people join the company, they will know, oh, okay, this is how we do stuff. This is how we build services. And most importantly, this is why we do it that way. We're not just like putting some rules that people need to follow and like no one knows how to explain why. So I think that this is the most important part, guaranteeing consistency. And the way that we chose to do that is actually by keeping the eventual consistency way, but now having a framework on how you do that properly. Because it's very easy to screw this up. The second thing is today we basically use RPCs between the services. This is working great, but as you start to have more and more services needing to contribute towards a common goal, you need a way of propagating data. And we chose to go not necessarily with an event-based architecture, but with a event-based data propagation implementation. We're maybe going to build that on top of Kafka. We are still testing that. And again, we are not using distributed Erlang here because this is something that that needs to go between all the services that we have, and they might not be in Elixir for some reason. And one important thing is we don't want to require having a nested database for a couple of reasons. First, they don't, at least not the most common ones, they don't tend to scale horizontally pretty well. If you take like the Postgres example, which I think it's the most popular nowadays, that thing doesn't scale horizontally. You can try to shard, you can try to use something like Citus data, but at the end of the day, the core infrastructure for Postgres wasn't built for that. And there are a lot of cool databases today. For most notable examples are Datomic, for example. It's a very good database when you need to version stuff, know when and why data changed. But it doesn't have all the constraints that Postgres offers you, and it clearly doesn't work the same way. Or for example, we could choose to use a graph database for data manipulation. We actually have a graph database for today for onboarding, which is basically a process where we need to verify that the customer is actually who he's saying that the customer is, and it tends that a graph database is very good for that. And I think that the main thing revolves around the execution model, which is how do you actually implement the business logic on the services? And I think we boiled it down to two very important steps. First, you do all your local work, which is change your database, insert new records, assert the new facts existing in your data model, however that works. If you do have ACID capabilities on your database, please use a transaction. If you don't, no big deal. Remembering to always do everything in an idempotent manner. And only after that, you propagate side effects. And the reason for that is, if you mix those, for example, I'm going to insert a new item here in my database, and then I'm going to tell a new service, oh, this thing exists. If you do that inside your transaction and you don't have distributed transactions, which it's not something that comes bundled with almost any framework or whatever you're using, you're going to have inconsistent data. What if that transaction rolls back? The other service might have a reference to that data, and that data doesn't exist anymore. Overall, what we do is we divide very well the two pieces of service invocation. So only after you make sure that all the data that you have is correct and it's saved, stored, committed, you propagate side effects. That could be just calling external services, publishing events, communicating with the customer. This is very important. I've seen that a lot in some places, actually. People send an email and then they roll back the transaction, but the email is already out, maybe with information that is invalid. So if you enforce this with your code, this works very well. And again, going back to Elixir macros, it's very easy to enforce that people to do that. If you, instead of just like declaring modules, you have some sort of syntax trigger that like divides very well the steps in here. So Elixir helps a lot with this. And I couldn't go over without talking about idempotence. I really think that in the 21st century, everyone should have idempotent services. Like everything tends to go to a distributed model, and if you just do this route, it's just easier. So it's one of the most important aspects with our architecture by far. The way that we implemented it is a requisite for eventual consistency. Otherwise, if you repeat a message that was sent, too bad, it's not going to work. And other than that, I think that an important point here is people generally think that it's hard to ensure idempotence everywhere. But so far, my view on that is, if you stop thinking about, for example, inserts and updates for people that are just used for with SQL databases, and you start talking more about upserts, or even the datomic way, asserting that a fact exists. You don't care if it's already there, you don't care if it's new, or if you're just updating, as long as it's data that you can update. Just put the data there. It's very easy. There are a lot of gotchas, especially interacting with external services. But overall, it's not that hard. I think that's the most important takeaway on this part. Just really quick over our build system today on the future. We are considering integrating with Bazel specifically for being able to build everything as a single step with the other applications. So this will be an interesting thing. We still don't know if we should just integrate Mix with Bazel, or if we should maybe invest in a more deep integration on that. Mix works very well for Elixir. But if you're trying to integrate into a more complex build system, you start to have some issues. Building releases, I already talked about it. It's something that we definitely want to do for a couple of reasons. And having smart build plans, we have a monorepo today with a lot of applications. So the build times, they tend to be long and getting longer and longer. So having smart build plans where you can actually know the dependency between stuff and parallelizing the more you can is actually something very good. If we integrate with Bazel, that's almost out of the box. But if not, we want to find a way of doing that. Another very interesting thing that we might have in the future, and this is something that we definitely want to share with the community as we start interacting more with open source stuff, is what I personally like to call the global query system. And basically that is, Ecto, for example, is very good for manipulating data. It's very easy to write queries, integrate it into the language. But as soon as you need to query another service, that's not that easy anymore. You can't just join across your data set unless you're sharing a database, which has a lot of issues if you're actually doing that. So basically, the global query system in my mind is kind of like GraphQL, but tailored for backend services. So why not actually integrate that into Ecto? That's something that I would love to have and build. So I could actually do joins cross services. And behind the scenes is just going to query all the services, given that they have, I don't know, a generic interface for querying for data. Another very useful thing that we find is today we auto-generate some of the GraphQL API that we have, not as much as we would like. And if we have a very well-defined data model and a very easy and standardized way of querying for data across services, we could maybe auto-generate 90% of any API that we could choose to expose. That could be very easy, especially GraphQL. And, well, last but not least, the triple A's, which was something very common to reference in the past. Nowadays, I don't think that people tend to use this name anymore. But today, we have a very simple authentication model within the system. Basically, the external APIs, they guarantee the authentication of the user and whether the user can perform the actions, be it like an external user or when communicating with internal tools, for example. But I don't think that scales very well with time, especially the authorization part and the accounting part, which is just a fancy word for trace audits and actually knowing when and why stuff is happening with your system. So we don't have a lot of ideas so far on what we want to do with this. But me personally, for example, I tend to think that authorization should be distributed downwards to the systems, not authentication. So something that we are considering to build is actually, as we have a standard way of communicating between any services, we might as well just start forwarding the authentication information with the messages. So the services downwards, they already trust that the information is valid because an external system said so and signed the message. And then you just need to assert, like, who is this person? Is this Brex customer interacting with the API, maybe through the dashboard? Or is this an internal user trying to do some administrative task? And if you actually internally make those behave kind of in the same way, it's very easy to, for example, expose new functionality to the users or maybe just to the front-end team if they need so, just by changing how an ACL is applied, however that works. And more importantly, it brings to the actual owners of the services to maintain this. So you don't have any more decentralized approach to authorization. And that's something that speeds up development time actually quite a lot. So yeah, this was just a very basic high-level overview that I wanted to give on our architecture. We're starting to get involved a lot with the community. We are actually planning on maybe sponsoring some projects, some open source projects that could help us in the community. And overall, I think that most of the stuff that we built so far, there's no reason for it to be just a closed piece of code that we have internally. So I think you guys can expect a lot of things coming out this year as we have a more structured team now with more people that can actually focus on those. And yeah, I really hope that a good chunk of the stuff that we do will be out for people to reuse. So thanks everyone, and last but not least, we are hiring. So if you got interested by any piece of stuff that we went over here today, or if you actually disagree and think that we should be building stuff like maybe differently, feel free to hit us up, maybe just for a quick chat, or if you're actually interested in joining, please. We are hiring for all available positions, and yeah, thanks everyone for coming. Still have 5 minutes, so if anyone has any questions.
If anyone wants to do a little challenge, if you test these out, it's actually a Brex credit card, but it's actually a $10 gift card, and you have to write your authorization.
Yeah, so you guys can get to interact a little bit with our tech stack in that. You actually need to spin up a webhook server and process the transaction and maybe write something cool or just like return authorized. Up to you guys. Let us know what you guys build with that. Cool. Well, thanks. Thank you, everyone.